over here.
All right.
All right, so sine. Well, first of all, that relationship. So Katoa. So sine is what, two angles? Opposite over hypotenuse. We're talking about angle A. We know the hypotenuse is 17. What's the adjacent side to angle A is going to help form the angle, which is 15. So this is my adjacent side to angle A, and 8 is the opposite side to angle A. So if we talk about the sine of angle A, what's it have a value of? 8/17. Cosine. Cosine is what, two sides? Adjacent over hypotenuse, which would have a value of? 15/17. And tangent is opposite over adjacent, which would have a value of 8/15. Now that's only 3 of the trig functions. So when they talk about 6, they talk about the reciprocals. What's the reciprocal of sine? No. What trig function gives you the reciprocal value? Cosecant. So we said a C and an S have to pair up. They have to deal with a C and an S. So cosecant of angle A is the reciprocal of sine, which would be 17/8. What's the reciprocal of cosine? Secant. So the secant of A would be equal to 17/15. And the tangent is cotangent, which would be 15/8. 15/8. Okay, now my question for you is, what is the measure of angle A? How do we find the measure of angle A? We talked about something 2 days ago. This is not, we don't know that this is a 30, 60, 90 triangle. If we start thinking about your hand, we don't know it's a 45, 40. It's not a 45, 45 because of these two sides not being congruent. The two legs are not congruent to each other. I start using the fingers, and then what did I end up when I talked about the ratios with the fingers? We have radicals involved. Do I have radicals involved with this? No. So we're probably not talking about a 30, 60, 90 triangle either. So what I have to think of is, I told you one way to find an angle. I was telling you that if you just typed in the sine of 30 degrees on your calculator, we know the sine of 30 degrees is what value? 1/2, or it's going to show up on your calculator as 0.5. And I showed you how to take that 0.5 and change it into a fraction. We showed how to take reciprocals. How do you take a reciprocal? You hit the x to the -1 key is what you hit. So if I had this as a value, and or even if it were as a decimal, I can't see the flip numerator denominator very well. So we use that x to the -1 key. But I said, don't let that x to the -1 power confuse what this is. What does this actually mean? What does that mean again? That key on your calculator. Nope. This is what means the fraction. X to the -1 means you're going to take a reciprocal.
Oh, that's what you just
What did this mean?
Like if you just have, if you already know the fraction or the whatever it's called, you know what I mean.
This right here,
Yeah. Like if
can
you
be
know
written
17,
as this down here. And when I use that shift key, go ahead and type that in on your calculator. Somebody needs to borrow one. I have to find the power charge. It's a hot commodity though, so be careful if you leave it there. I do know one person that's missing theirs. So if they see one there, they may try to take it.
Who's the one person?
It's a senior. So did you need to borrow, somebody need to borrow one? Does someone need to borrow
So
one?
you type in 8 divided by 17.
You can, as you type it in. Okay, here's a little bit about your graphing calculators for those of you that have the graphing calculators. Okay, just let me ask this. Okay, when you type that in, I'm going to see what it should be first before I start asking you questions. I think you get that. So it's a 28-degree angle. It's close to a 30, 60, 90 triangle, but it's not quite. When you get that, that's telling you that your angle is 28 degrees. Now here's how to use your calculators. For those of you that don't have a fraction key on your calculator, you're going to type it in as you're going to hit that inverse sign key and then just hit in parentheses, hit 8 divided by 17. And then hit your equals, and that should give you your 28-degree angle. Now, some of you have the fraction key. If you have the fraction key, if you're not using the graphing calculator, you know where a fraction key might be. Yes, no? I don't know. On a graphing calculator, on a graphing calculator, you go out, hit your alpha key, and then hit y equals, which is right underneath. It's the first key right underneath your display window. So you hit that, and the very first thing it's going to do is put in a fraction for you. So if you hit enter, like hit enter on that number 1 that pops up on the bottom there, hit enter and it's going to pop up as a fraction for you, and then you can type in your fraction. So the way that you would hit it, the keystrokes you would have to use, actually you would have to hit the second function key, then you'd have to hit the sign key, because what you're wanting is this sign to the negative first, and then you're going to hit the alpha key, and then you're going to hit the y equals key. I think it's a lot of steps to hit that fraction. So then you hit the y equals key, and then you're going to do the number 1, which is going to be given to you as like u over d or something like that. But I think it's the number 1. You just hit enter. Maybe that'll get it for you. Hit enter. Maybe that's what I'll do. Then hit your enter, and then you're going to have to use the arrow keys as you type in your 8 over 17. A lot of keys. Even on the graphing calculators, you can still just type it in this way, which is a lot less keystrokes than it's going to be to type in that fraction. Did everybody hear that?
Yeah.
It's a lot less steps to type in. You can still type it in this way.
Except when we get like that. So that's when we need to find the angle.
That's when you find the angle. When you find the angle, you have to hit an additional key, AA, angle additional key. That additional key is second function before you get there. Oh, we're going to talk about how to find different links.
What did we do yesterday when we did
That's going to give you the ratio. It's not going to give you a link. It's going to tell you that we were just using sine, and we'll get to some of that, but that's not going to tell you the actual length. It's going to tell you the fraction of the comparison of two sides.
So what would you type in?
For this one, I would type in inverse sine and then 8/17.
Yeah.
This is to find the angle. Let me tell you this. If you do this, okay, what's 8/17 is up as a decimal? Take 8 and divide by 17. Tell me what that is as a decimal. 8 divided by 17 is the same thing as 0.47. Okay, so then if you were to take your calculator, now if you want to know that value, what you were doing with your calculator the other day was this. What is the sine of 28 degrees? take the sine of 28. So hit your sine key, type in 28, and that should give you close to that 0.47 value. It's not telling you 8, 15, or 17. It's telling you the ratio between the two. Remember, your calculator needs to be in what mode? Degree. So make sure it's in degree mode. Okay, so you have your notes sheet, right? I think we're ready for the second page of the handout that I gave you, that Jackson ironed. Okay, so the first question, they give you this triangle, JKL. They give you a triangle JKL, and they say find the exact value of sine L. So sine of angle L. What is the sine of angle L? Opposite over hypotenuse, which is going to have a value of 15 over 17. Now, some of you choose to type that in on your calculator, and you're going to sit there and you're going to go, well, 15 divided by 17 is 0.88235. Yeah, I think 0.88 looks like a good answer. But what's it tell you? Well, I'm going to say you guys looking at 0.88235294112, you're just going to stop at 88. It's a nice number there. I really doubt, but I did say carry out to 3. So if I told you to carry out to 3 the other day on the paper, you're going to look at something like that. Now it says, what is the exact value? Which one are they looking for? They are looking for the left. They are looking for 15/17. Why? This is what? That's rounded to 3 decimal places. That's not exact. That's why we've been doing things in terms of pi instead of letting pi be 3.14. That's why you do calculations with it left in radicals, is because those are exact calculations. Okay, they ask you for another one for that particular triangle. What is it? The secant. They ask for the secant of angle L. So when you're asked that, you have to think of what? So I'm going to do my little thought bubble. Secant is the reciprocal of what? Cosine. So I think of the cosine of angle L, which is what? What's the cosine of angle L? 8/17. And then what do you have to do to that? Flip it. So the secant to angle L is what value? 17 over 8. Consequently, why I've had a little bit of your bell ringer led to a little bit of this. The next one. Now be careful of this next one, because it asks you what is the tangent of angle K. What did they do different here? They switched your angle. So if you look at angle K, what is the opposite side? 8. 8 is the opposite, and 15 is the adjacent. Where before, when we talked about the sine of angle L, opposite over hypotenuse, that opposite side was 15. But that's because I was referring to a different angle. So the tangent of angle K is 8/15.
What will they say when they want to know the angle?
They're gonna, we'll look at it.
If you have an opposite angle, that'd be not hypotenuse. You can't do that. What would be the adjacent one?
If they're going to ask for an angle, they will say find that angle, or they will use that inverse key. They could, if they want you to find that angle, they would say find K given the tangent of K is equal to 8/15. They could say what is the arc tangent of 8/15. That would be asking for the angle. They could say the inverse tangent of 8/15. That would be asking for the angle. So these two right here The question is, what is the angle measure? That's what they're asking for. But right now, they just want to know what is that ratio between the two. Okay, so we look at the next diagram. Next diagram, you have A, B, and C. You do not have any side links. But if you read, what is the given information? They tell you it's a right triangle, and they say you are given what piece of information? The tangent of angle A is 9/12. So if the tangent of angle A, if you think about the tangent of angle A, the tangent of angle A is what two sides? Opposite and adjacent. What is the opposite side? BC. What does it have a length of? 9. And AC has a length of 12. Yes, it is, if you think about it, it is a 3, 4, 5 triangle. So what is AB have a length of? 15. It's a scale factor of 3. Now, if you don't recognize that, you're going to use Pythagorean theorem. 9 squared plus 12 squared, and then take the square root. You're going to get 225. The square root of 225 gives you 15. You'll still get to that same answer. Okay, now what they want, though. Here's what they want. They want to know what is the cosecant of angle A. So we got to do our thought, right? What do you think of when you see that inverse, or well, not inverse, but the reciprocal function? Cosecant is the reciprocal of what value? It's the reciprocal of sine. So you need to think of what is the sine of angle A. The sine of angle A is what? 9/15. That's what I think of. So then I can get to the cosecant of angle A, which is what? 15/9. You sure? Never mind.
Yeah.
Cotangent. What do we think of? Well, I don't know. Some of you could do this. Some old hippie caught another hippie tripping on acid. So I said go backwards. So if you don't want to first think about what is the tangent of angle A, the tangent of angle A is going to be what? Tangent. It's 9/12. So then what is the cotangent? So the cotangent is going to be 12/9. Now, as you look at that, some of you, I said if you glance up here, you could go the reverse order. So cotangent is going to be the reciprocal of tangent. So you're just going to flip these two. Instead of reading opposite over adjacent, you read it backwards. It's adjacent over hypotenuse. So the adjacent side is 12, the hypotenuse is 9. If you look at cosecant, you still have to know that that is the reciprocal of sine. So you go to sine and read it this way, which is going to be hypotenuse over opposite. So it's going to be 15/9. Sometimes people like to think of what is the original function, then flip it. Other times people like to think of this phrase and flip it here. I don't care. The last one says, what is the cosine of angle B? What is the cosine of angle B? Nine over 15. What did they, it is adjacent over hypotenuse, but what did they do? Angle B. You have to find angle B, and this is the adjacent side over the hypotenuse. So be careful of which angle they are asking for. Got to read it carefully. Okay, do you have a question over that?
So you don't have like, if you don't have it memorized, like sine is opposite over hypotenuse, you can find that by like looking at something or like
For the reciprocals, you can. So here's the way you do it. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cotangent is adjacent over opposite. Secant is hypotenuse over adjacent. And cosecant is hypotenuse over opposite. Any other questions? Okay, the next part. Trig values for special angles. I have those two posters up on the board. And the first special triangle that they give you is a 30, 60, 90 triangle. This is going to be a famous question, probably, that could possibly be on an ACT test. I don't know about famous, but remember, it's a time test. So if you can recognize special triangles, it's going to be an easy, quick calculation. Now, you don't have to memorize that figure right there, but you could. This one, they just put x instead of n. So we could talk about how this is x. The hypotenuse is going to be 2x. And opposite of the 60 degrees is going to be x radical 3. Now, all of this can be found using your hands. If I look at this, sometimes it's stated that a 30, 60, 90 triangle is in the ratio of 1 to radical 3 to 2. And all they're talking about is the side opposite. So if I go with 30 degrees, the side opposite of that is x. The side opposite of 60 degrees is radical 3, and the side opposite of 90 degrees is 2. You think about this, where's the longest side in your triangle? The hypotenuse. Is 2 greater than radical 3? Yes, because the square root of 4 is 2, so the square root of 3 is less than that. That can all be found with your hand. You stick your hand out here, and if you want to know that ratio, where is 60 degrees? Which finger? Pointer finger. So if I fold in the pointer finger, what do you see? 1, radical 3, 2. That's that ratio. Right there. 1, radical 3, and 2 in the palm of your hand. It's there. You do not have to use this triangle because you can use it here. You can use it here. Because if I look at 30 degrees, if I said, what is the sine of 30 degrees? And I'm using that in this figure right here. So I'm going to use this figure, 30 degrees. Fold in your 30 degrees. What is the sine of 30 degrees? No. It's alphabetical order. It's cosine, sine. So sine is your bottom one. 1 over 2. So it has a value of 1/2. Looking at this triangle up here, here's how you would use the triangle. It's the opposite over the hypotenuse. What's the opposite side? 1x. What's the hypotenuse? 2x. How does that reduce? 1 over 2. It's there. You look at this figure right here. Give me a function, sine, cosine, tangent. Tangent. So if I talk about the tangent, give me an angle measure. Do you want 30 or 60? 60. The tangent of 60 degrees. If we use this up here, 60 degrees, tangent is what over what? Opposite over adjacent, which is going, what's the opposite side in that triangle? X radical 3, and the adjacent of 60 degrees is x. That reduces down to radical 3. Take your hand. Take your hand. 60 degrees. Fold it in, which is which finger? Pointer finger. There's 60 degrees, and you look at your tan. What is it now? This is tan, so I have no fraction, so it's this over this. So it's radical 3 over 1. Is that the same answer we got right here? Yes. So, do you have to know this right here? No. Could you? Yes. You could. You could use it. I'll show you different ways you can use it later.
Wait, why do you mean you don't have a fraction?
I mean, you don't. Over here, our fraction, here's where it comes from. You do have a fraction here. Sorry, I don't mean it that way. I just mean that the denominator is not here on the hand. It's between your bent in finger. That's your fraction mark.
Wait, so then what?
You would have to do that for 30 degrees. So you fold in 30 degrees, and the tangent of that is radical 1, which is what? 1 over radical 3. We're going to do that one right here because that's a good one. What if I said the tangent of 30 degrees? There's two different ways that you might see that value. The tangent of 30 degrees, some of you, are we resorting to this hand? 0. 0, 30, 45, 60, 90. So 30 and flip it, and that's going to be the square root of 1, which is 1, over the square root of 3. There's your value. Now, some people are going to rationalize that denominator. I don't know if your college professor will do that or not, but if you rationalize that denominator, you need to multiply by what? Radical 3 over radical 3, and you end up with radical 3 over 3. That's the same value. So you could have an answer of 1 over radical 3, or you could have an answer of radical 3 over 3. And I think we looked at a sine, cosine, tangent chart on the board the other day. If not, it was in one of the videos that I did. And I said 30 is happy. You got 3 3s going on. The tangent of 30 degrees is radical 3 over 3. There's 1 3, there's a 3, and there's a 3.
So how would you say the sign of like 45?
The sine of 45 is sine in the top fingers or the bottom fingers? That's cosine. You're in alphabetical order. We write cosine sine on your hand. Just like x, y, alphabetical order, cosine sine, alphabetical order. So you got radical 2. And remember, in the palm of your hand is that 2. So it's radical 2 over 2. That is sine of 45 degrees. Cosine is still radical 2 over 2. And you think about it, it's the ratio of two sides, and it's the same thing. It's this over this, or this over that. Now keep in mind, there's the other thing. And I'll look at that here in just a minute. Are we okay with this?
Yes.
So the other special triangle is a 45, 45, 90 triangle. I don't know how to set that. I tried to figure it out and I can't. But I like the finer point here, so bear with me as I have to keep clicking that. All right, they say it's in the ratio of x, x, and x radical 2, right? That's what it is. Now, if we use the hand trick and we say, what is the sine of 45 degrees? You're going to pull in your finger, and it's going to be what? Radical 2 over 2. Now, that should not be confused with a different answer somebody might have, which goes back to the last example that I talked about. If I look at this diagram, this special triangle, and I say, what is the sine of 45? I don't care if you use the top or the bottom angle. Sine is opposite over hypotenuse. What's the opposite side? X. What's the hypotenuse? X radical 2, which when this reduces, that's the same thing as 1x, you get 1 over radical 2. That's not to be confused with radical 2 over 2. Because if you rationalize that denominator, you're going to multiply by radical 2. And what do you end up with? Radical 2 over 2. Yeah. Sometimes that tells me what way you are thinking of it. If you're looking at this triangle, you're going to get 1 over radical 2. If you use the hands, you get radical 2 over 2. Yes, Wilson? I like, because when it gets up here in the bigger line, I think it gets kind of, I don't think it's as easier to read with the fat thickness of your line. Okay, now I don't care, I do not care if you use the special triangles for that. But I'm going to resort to the hand because I think the hand is a lot easier myself. You do which one you like. Okay, so Abby's probably not going to see much on this one because she's not here. She's supposed to be looking at the video. I can try. So the first one says the sine of 30 degrees. Here's your pointer finger, ring, or middle finger, ring finger, pinky. All right, remember? Are you laughing? My pinkies always get fat. I'm sorry. Are you laughing at my fingers? That's why. This is why, Wilson, when you were watching that video I recorded for Austin, my girls were laughing. It was because of my hand. Okay, so we look at the important information. As we look at that, here's what you're going to put. If you had markers on your hand, you would have what? Cosine, comma, sine. Remember, that means x, y coordinate point. What's right here in the palm of your hand? A 2. All right, they want the sine of 30 degrees. This is 0, 30, 45, 60, and 90. So what are we going to do? The sine of 30. So I'm going to fold in this 30 finger, right? Sine is what? The top fingers or the bottom? The bottom. How many fingers is that? 1. So you're going to have 1 over 2. There's the sine of 30 degrees. Yep, 2 is in your hand. So it's the finger over 2. So you go to the next one. Okay, I'm going to back up so I can use my same fat pinky, okay? And I don't have to draw the hand all the time. So we back up. Okay, I hit the arrow back key. Arrow back, another one. All right. You look at the next one. You go down or across? Down. The next one says, oh, and I didn't have to, the cosine of 30 degrees, right? So you're going to take your hand and 30 degrees, which finger? Ring finger. So you're going to pull it in. So I'm going to bend this finger down, and it's the cosine. Is that the top or the bottom set? The top. How many fingers are there? 3. So those are radicals, remember? So that's radical 3 over 2. There's the cosine of 30 degrees. Now, if you look at that special triangle, we could look at that special triangle. Here's 30 degrees. Here's 60. And the cosine of 30 degrees is the adjacent side over the hypotenuse. What happens? The x's cancel, and what are you left with? Radical 3 over 2. Now, would you want to memorize this triangle, or do you want to take your hand with you? It's up to you.
So, like, will you ever?
The triangle, what's going to happen is that on an ACT test, they might give you that this is 30 degrees, and they will tell you this is 5 and ask you what that is. If that's the case, what is the relationship between those two? What do you do to this to get to that? Double it. So what's x going to be? 10. That's the only reason. Or they're going to ask you, what is y? What's y going to be? If that's 5, what's y going to be? 5 radical 3. So this would be 5 radical 3, and this would be 10. But you can find it otherwise, and I'll show you how you can find it just using your fingers. There's just like, is 3, 4, 5 a special triangle? When you're talking about side lengths, you talk about a 3, 4, 5 triangle. You could talk about a 5, 12, 13 triangle, those special triangles. But when you talk about angles for trig functions, those are the 2 important ones. The ones that involve angles of 30 and 60, and the other one is 45, 45, 45, 90 triangle. And more than likely, if they're asking you to calculate, they're probably going to use a 30, 60, 90 triangle or a 45, 45, 90 triangle. So let me draw my hand again, since I've kind of added that other triangle on there and I didn't want to. All right, we can laugh again. We'll draw my hand. There's your thumb. Okay, I will. You think it's so easy.
There you go.
Your hand's not straight there. Though. Look at it. Dips down. That's all right. My thumb's really awkward in this one. I might have to change. I can't keep this one up here. 0, 30, 45, 60, and 90. All right. What do they want for this one? The tangent. Oh, great. Now you guys get to see my other fabulous work. All right, tangent of 30. What's the first thing we want to do, though? You fold in your 30 degrees because we don't write out here. It'd be nice if you could, because then you could just do fingernail polish and they would never know for an ACT test, probably, right? All right, you fold in 30 degrees, but then what do you have to do? Flip your hand. All right, here we go. So there's your pinky. There's your ring finger, your middle finger, your pointer finger, and then we have our thumb. This is that last finger always gets me. I'm sorry. I don't care. And your thumb, but what finger did we fold in? The ring finger. So this was folded in, and we are looking for the tangent, right? So we got to look at our tan. You flip your hand over, and it's just your fingers. So how many fingers up here? 1 over how many? Right, 3. So the tangent, I don't know what it's doing right now. It's probably thinking, man, that's really bad. You sure you want to save that up there? So the tangent of 30 degrees is equal to 1 over radical 3. Now, if you rationalized your denominator, what's another answer for that? Radical 3 over 3. I do not care which one you use. Yes. How do I know what? The pinky is actually radical 1, but what is the square root of 1? 1. Anytime you work with your fingers, they are radicals. So like if I did the tangent of 45 degrees, fold in that, flip it, it's radical 2 over radical 2. So fingers are always radicals. It's just when you have 1, it's just 1. They won't leave it as the square root of 1. All right, I corrected the thumb. That's not too bad, is it? It's probably better than the thumb on the green there.
Okay. 3 over 3 be the same answer?
Yeah, I put that up there. Yeah. Okay, now let's look at the next one, because the next one is, now I got to draw my hand again. You're going to, now you got to be careful when you say flip, because flip doesn't mean this. So as long as you just keep in mind, pointer, ooh, that's getting, oh, and the ring finger's longer, but that's okay. I'll just get the pinky shorter. I don't think it is, but that's okay. All right, what's this? 0, 30. Okay. See, we got those down. No, wait, now we don't have to draw in our hand anymore. Okay, so we look at it, and it says cosecant. So I think of when I see cosecant, what's that the reciprocal of? Sine. So I have to think of sine. The sine of what angle measure? 30 degrees. So I fold this in. What's the sine of 30? So here's your thought bubble. The sine of 30 degrees is 1 over 2. So what is the cosecant of 30 degrees? 2 over 1, or just 2. There's your answer. Probably. Now, if you didn't like that, here's the other thing that Anna asked about. Some old hippie caught another hippie tripping on acid. As you go this way, this is cotangent, right? And as you move across, what's the reciprocal of cosecant? Secant. Oh, yes. I said it wrong. Cosine. What I was saying and what I was asking for are two different things. My head, what I was seeing here. Cosine, the reciprocal of sine is secant. And then if I keep, I don't know how to write that up there. Let me do this again. So if we go backwards, Anna, that's going to be cotangent is read this way. And then what's read this way? Secant, because that's like backwards of cosine. So if I was spelling it cosine going this way, when I go backwards, it's like writing it backwards. And then what's this one right here? Cosecant.
Yeah.
So they ask for the secant. That's not going to be adjacent over hypotenuse, it's going to be hypotenuse over adjacent.
With the secant.
This is your hypotenuse.
with the
So
secant-
it's 2 over 1. But I just like to think of it as what is it here and then flip it. This is what my mind does. Yes.
Well, the secant of 60 degrees, would that be 1?
The secant of 60 degrees. So we're going to pull in 60 degrees. Secant is the reciprocal of what?
Cosine.
Cosine. So what is the cosine of 60 degrees?
Radical 1 over.
No. What's here?
Oh, that's 2.
2.
So it's.
So it's 1
radical
half,
2, which is 2.
which is just 2. Okay, what you need to do for tomorrow is you need to finish the bottom of this page right here.
What is that?
Your second page of notes, you need to answer from the sine of 30 down to the cotangent of 45 degrees. I've already answered quite a bit of them.